Example 3. We're going to find the limit as x goes to infinity of 5x plus sine of x all divided by x. So before we actually look at this limit, we're going to talk about what happens if you just plug in infinity. Well, first of all, this piece is going to go to infinity. And then sine of x, we know that this graph looks like this. So then actually it looks more like this repeatedly over and over. And as this goes to infinity, the limit does not exist because it oscillates back and forth. And then this piece, if you plug in infinity, goes to infinity. So we end up with infinity plus do not exist divided by infinity, which makes no sense. So what we're going to do is we're going to do a little bit of algebra to determine this limit. So we get that this is the limit as x approaches infinity, and I'm going to separate the fractions, so I get 5x divided by x plus the limit as x goes to infinity of sine of x divided by x. Now we know that this limit right here goes to 0 from the last example. And then our first piece is going to reduce the x's off. And so this is the limit as x approaches infinity of 5 plus 0. And the limit as x approaches infinity of 5 is just 5 plus 0, which is equal to 5. So this one I want you to try on your own. This is the limit as x goes to infinity of x times sine of x plus 2 sine of x all divided by 2x squared. So we're going to implement the same idea when we solve. So here we go. So this is the limit as x approaches infinity of x times sine of x over 2x squared plus 2 sine of x divided by 2x squared. And now we're going to do some reducing, so I can get rid of an x here and an x here, and I can get rid of the 2's here. And now I'm going to get that this is the limit as x approaches infinity of 1/2 times sine of x divided by x. And what I did here, this allowed me to break this up so I get that sine of x over x, and the 1/2 came from this 2 being in the denominator. And then I get plus 1 over x times sine of x divided by x. And this came from the x squared right here. One of the 1 over x's went here, and the other one went right there. Now I'm going to break up this limit piece by piece. I get this as limit as x goes to infinity of 1/2 times the limit as x goes to infinity of sine of x divided by x plus the limit as x goes to infinity of 1 over x times the limit as x goes to infinity of sine of x divided by x. So now I can do this piece by piece. So this piece of the limit is going to be 1/2 times this piece of the limit, which is 0, this piece of the limit, which is 0, and this piece of the limit, which is also 0. So I get 1/2 times 0 plus 0 times 0. So this becomes 0 plus 0, which is just 0.